All right, let's talk a little bit about the families. The families, again, are the columns, the vertical columns on the periodic table. And as you can see, there's some distinguishing marks between them, and some are a little different. Each family kind of has the same characteristics. So, like the elements in the first column, they exhibit similar characteristics to each other, and that's why we're able to group them into this category. Group 1, column 1. They are called the alkali metals. Hydrogen, although it is in column 1, it's not a metal, but it is in that category, kind of like in that same column, because it kind of exhibits similar properties, as in it will bond similarly to these metals that we have here. Notice they only have one valence electron in their outermost shell. So they're going to do anything they can to get rid of it. So they are very reactive metals. They're soft silvery. If you put them in water, they will explode. They are the most, again, reactive metals. They conduct electricity, and they all burn different colors. So like potassium burns purple, and we can use these in creating fireworks. Alkaline earth metals are also used to create fireworks. Alkaline earth is in column 2. All right, so we have alkali metals, and then we have alkaline earth. The way I remember which one's which is alkali is one word. That's the first column. Alkaline earth is 2 words. That's the second column. That's just one way I remember it. These guys have 2 valence electrons, but they still want to get rid of those 2 electrons, giving them a overall positive charge. They're white, malleable, reactive still, but they're not as reactive as the alkali metals in column 1. High melting points, burn different colors, conduct electricity. All right, in the middle, we typically skip over this. These are called the transition metals. Transition metals. They're good conductors of heat and electricity. Some are used for our jewelry. So there's our silver and our gold in there. We have platinum. Then what we do is we can take these and we can make mixtures and create alloys to create other different things, other different items that we use in the world. So like we can take them and make steel out of them. We can take them and make brass to make our instruments. Those are mixtures of these. Brass and steel are not elements, just to talk about that a little bit. All right, so they're hard, they're strong, they're shiny. They can bond with many different things. We typically don't talk about their valence electrons as a whole, because they have a variety of valence electrons that they're willing to get rid of. So like, for example, iron. Typically, iron will either lose 2 or 3 depending on what it wants to do. So we have an iron with a +2 charge or an iron with a +3 charge. So it reacts differently to make different compounds out there. So that's why I don't talk typically about their ions and their valence electrons. And this is just because they have all these like inner electrons that we don't talk about until we get to chem. Just mentioning it now. All right. Then what we have, we're going to talk about boron, carbon, BCNO, boron, carbon, nitrogen, oxygen families. So they kind of like are get grouped together. So we can call them BCNO, we can call them boron family, carbon family, nitrogen family, oxygen family. Basically, boron family, the top part, we're talking about 3 valence electrons. Most of them are metals, but boron, the first one there, is a metalloid. Right, then we have group 14. Group 14 can be called the carbon family, but it's again part of the BCNO. So we have nonmetals, metals, metalloids all here. We talk about like carbon has 4 valence electrons. All right, we have our column 15, our nitrogen family. Again, in the BCNO, still contains metals, nonmetals, metalloids. They have 5 valence electrons in their outermost shell, so the nonmetals in this family will gain electrons. All right. Then we have our oxygen family, so that's column 16. We again still have our metals, nonmetals, and metalloids. They are reactive oxygen, especially oxygen will bond with anything. It only needs 2 more electrons. So it has 6 valence, only needs 2 more to fill its outer shell. All right, and again, our nonmetals are going to be the ones that are going to gain those electrons. Then we have our halogens. Halogens are the most reactive nonmetals out there, and that's because they have almost a full outer shell. They have 7 valence electrons. They only need 1 more to fill that shell, and so they're going to bond with other things just so that they can get that extra electron. Typically, you're going to see halogens forming bonds with alkali metals. It's because alkali wants to get rid of one and the halogens want to gain one. All right, they're all nonmetals. Some of them are poisonous. Think like chlorine gas. That's not good. They're poor conductors. So think about all the properties of nonmetals. Then we have our last column, the noble gases. They typically don't bond with things. Most of them, like you'll see randomly, xenon forming bonds, but otherwise they're not going to form bonds. And that's because they have full outer energy levels. So we call them inert. They don't react with things. They're unreactive. They exist as gases. They're colorless, tasteless, odorless. Helium only has 2 electrons in general. So when a lot of people say, well, noble gases have 8 valence electrons, well, helium doesn't. Helium only has 2 electrons in general, but in that first shell, we can only fit 2 electrons. So it still has a full outer shell. So these are non-reactive elements. And in one of our videos that I have for you guys, it talks about how if they're charged with electricity, they're going to have different colors. So a lot of people think about the neon. All right. Rare earth metals. Those guys are given so many different names. So we have the lanthanide and actinide series, and it's based on the first 2 elements that make them up. All right. So those actually go this way. They go left to right. So lanthanide series, actinide series, and they're actually taken out just so we can see it and kind of scrunch the periodic table together. But they're actually like right here. And so we have typically a longer periodic table, but it makes a nice periodic table if we pull them out a little bit. All right. Some of them are radioactive. You'll see uranium down in there. You'll see plutonium down there. So those are just some interesting facts. All right. I believe this is the end of our PowerPoint. I hope you learned a little bit of something and maybe I clarified some pieces for you. And I hope you guys have a great day.